Welcome to Cory-Rawson High School, and this is Mr. Blake. I have advanced organic chemistry class here at Cory-Rawson. It's not advanced organic, it's advanced chemistry, topics that we expanding on in general chemistry, plus organic chemistry. And I want to say first off, thank you very much for the grant. It makes a lot of what we do possible or easier. Expands our opportunities, certainly. So our project was toilet paper moonshine, and I'm going to call this a successful failure. If you think back to Apollo 13, they never made it to the moon, but they got the astronauts back alive. So they accomplished the greater mission. So our experiment was not successful in that we did not end up with alcohol, but we not only achieved all of our learning objectives, we probably added others. So this is what the grant purchased, was this cellulase. It turns out, after I thought about it, that I missed the obvious answer. Anytime you do one of these new labs, for example, we have a lab, what I've been doing since I started here at Cory-Rawson a few years ago, where we take aspirin and we do a number of reactions and extractions and filtrations and all kinds of things that we do. And it takes about 2 weeks. We turn that into wintergreen oil of wintergreen, methyl salicylate. And I've never done that lab home run to where everything went great. And so when you do one of these projects, it takes a while and several trials to get the success rate that you want. It's not usually a one-off. It turns out that to do this lab, I could have done this lab with toilet paper, liquid plumber instead of lye, which liquid plumber is lye, Rid-X instead of cellulase and amylase. So we spent more than we needed to, but I know that now. Rid-X, we'll try this in the future with just a box of Rid-X. So we'll try a technique to kill all of the living things in it and use the cellulase and amylase that are in the Rid-X. I think it will actually work better and be easier and cheaper. So here's the two students involved. I don't have them in this because security issues, but so you don't see them in a lot of the pictures. And what they're doing here is using a meter stick and some weights to get the mass of the toilet paper. So as we're dealing with students that have a Google mindset and they've always had an internet and information and misinformation is right at their fingertips at all times, what they lack today is creative solutions when you don't have what you need. So we didn't have a balance. You can't put this big roll of toilet paper on a 4-beam balance from the laboratory, and we don't have one big enough in the lab that's a scale, electronic scale. So we did have the simple machines equipment out, so let's improvise. When you don't have what you need, let's innovate and improvise. So this is something I'm always trying to teach in class. It's something kids today probably don't have as much experience with as people in my generation and older that grew up without resources, so you had to improvise to get what you needed. So we weighed it this way, and we calculated torques. And so they got experience doing that even though they're not in physics. So we made our own homemade balance, basically. And this is one of this is the large electronic balance that we have. So you have written on here, capacity 500 grams, and we needed about 750 grams of toilet paper. And the student here is mixing up the lye solution from a powder. You can get that at Ted's Market in Pandora. People use it for soap making. We use it for soap making when we can get to it. So mixing up the lye. We're gonna boil that with the paper. Here's the student taking the paper down, mashing it up with their hands. Okay, and then boil that in the lye. Put the lye in there and boil it. And some of these things had to be done off hours, or steps were dangerous, didn't want the students doing them necessarily. So we boiled that with the lye, poured the lye in there, mixed it up, boiled it good. for quite some time. And then filtered the lye out. So this is lye water. This came out. And then you're left with paper pulp that, instead of big, huge molecules of cellulose in the paper, which is what paper's made of, which is made of sugar molecules assembled into big cellulose molecules, chops those molecules way down to where they have a lot more ends for the enzyme to attack. So we're left with the paper pulp. And this is the paper pulp put back into water and the cellulase put in with it. And this worked great for a while. And it had to sit there over a couple of days. I came in on a Saturday and it smelled like overcooked spaghetti, perfect. Cellulose is breaking that down. We're getting amylose in there. Smells like starch. And the next day when I come back on Monday morning, we had this, which is a red fungus growing on the top, and it smelled like infected feet soaking in rancid milk, which is horrible. So the idea of, gee, we'll make this alcohol and maybe somebody will taste it, that went out the window. In fact, this was the death knell of the whole project, because once the fungus is in there and it's making toxins, you can never get the toxins out. We tried, but it doesn't work. So this was where the project was derailed, let's say. But it was wonderful on Saturday, and then Monday morning it was this. Okay, we tried killing off the fungus by putting alcohol in it, methyl alcohol, which will boil off pretty easy. Boiling it, which killed the fungus, got rid of it, but the toxins that the fungus made are still going to be in there. Okay, the big cellulase molecules are broken down, and there was amylose molecules. I should say cellulose molecules. There were amylose molecules, which is starch. So I put some amylase in there, got that cheap. Put some amylase in there, broke it down and made sugars. Now, we know we made sugars. Here's us stirring in the amylase, one of the students. Because earlier in the year, we had done a test for sugars. And so the students knew how to do this. So we tested the lye solution, and there was no really detectable sugar in it, but there was lots and lots of glucose, reducible sugar. That part worked really well. So our technique worked, it's just we got an infection. And if you talk to anybody that does brewing, trying to avoid infection is a problem. And it's a really difficult problem in this lab because you have to keep that cellulose solution with the pulp at a warm, nice temperature that the enzyme works effectively. It just so happens that's when the infection materials, the bacteria, fungus, that's when they work effectively too. So we've got to find a way, and that's the Ridex thing, to try to separate those two processes so that we can do them maybe at the same time, to where we're making sugars and consuming them with yeast at the same time. Okay, but yeah, we produced lots of sugars. I was very impressed with the success of that. Very, very strong response. Now it's just a matter of draining the water off, and here's your pulp. And what drained through here is your sugars. So this is cellulose that didn't break down. We had way more than what we need. What drained through was the sugars that we made. So now we're after what's in here. And what I did was, okay, put this in a pressure cooker, kill everything in it. That way if three bacteria or three fungus got in there, they're not fermenting in there with the yeast, ruining it. So this part I did at home and cooked that off. I also did this on a day where it was cool and damp, and so we got a chance to talk about some of the other principles where there's an ice on here, on the propane tank, and why it's there, and heat of fusion, heat of vaporization. So I wouldn't have done this step and had to talk about these things if everything had gone nice and perfect. But took that home because this is kind of dangerous. I don't want students around pressure cooking. And cooked that. And then tried fermenting it in here. We pitched the yeast in this classroom. And plenty of glucose, plenty of yeast. The problem is the fungal toxins are still in there and there's no way to get rid of them. So this was kind of where the experiment ground to a halt. Not all that bad, because the rest of this, the distillation processes, we've already done in other labs. So they didn't lose anything, any knowledge or understanding about the distillation process. We've been doing that all year. It would have been nice to get this far and see the fermentation happen with the bubbles and the alcohol produced, and then do a distillation that we've already done a few times. But all of the content and material they needed to learn, they got. And since we had to face challenges, they got more. So that's where we are. I don't know if we will try to get some wort and continue this on. Right now we've moved on to other topics we need to get to. But we'll kind of let them decide what direction we want to go with this, if we want to come back and try to pick up with some wort with brewing wort. But very much appreciate the help. I think it was a very effective learning tool to try this lab. And we're going to try it again in the future, make some adaptations, and keep working at it until we can get it right.